All right, guys. So we are on the third day of working on your review. We honestly do not have that much left. I know it seems like it's been 100 years that we've been working on this. But go ahead and turn to number 72. Okay, that's kind of where we're leaving off here. So I want to start actually on this page with number 76. Okay, so look ahead at number 76. So we have our function. It says it's twice differentiable. Then it tells me I have a horizontal tangent at 1. So that means that at 1, my graph is perfectly flat, okay? So it says which of the following must be true. Now, look at all your answer choices. You're comparing the same three things over and over again. F prime of 1, F of 1, and F double prime of 1. Okay, literally over and over again. It's just the same three things, just in different orders, basically. So if I'm looking for F of 1 is the y value of this graph at 1. Well, I can see it's above the x-axis, so I know that's positive. F prime of 1 is the slope of the graph at 1. And remember what they told me, I have a horizontal slope at 1. That has to be 0. F double prime has to do with the concavity. And I can tell from this graph that it's concave down because of the way that it's bent. So that means that my second derivative must have been negative. So that's going to really help me when I'm trying to put these guys in order, right? Because I know the negative is going to be the smallest, F double prime. So I can cancel these three out. I know those are not right. And then D and E are the only two left. So if this is the smallest, well then if this is positive and this is 0, then I know that's the next smallest. So I would want F double prime, F prime, and then regular F. So it would have to be E. Okay. All right, let's jump up to number 75. So 75, you have an equation, okay, but all of your critical numbers are letters. Okay, so what's going to be tricky about this is I can't really do a sign chart on it because how am I going to pick a number that's bigger than A or bigger than B, right? So this is really going to test your understanding of whether something is a single or a double root. So first thing I notice is I have my F double prime here, and I want to know where points of inflection are. Points of inflection are where F double prime changes sign. I don't care which direction the sign change happens, but I know there has to be a sign change. So if I set this function equal to 0, okay, then I'm going to have 0 equals x minus a, x plus b squared, and then x minus c cubed. Well, then I know that my potential sign changes are going to be x in the front is a 0, x minus a gives me an a, x plus b is going to be a minus b, and then x minus c is going to be a positive c. But one of those is what's called a double root, and a double root is where you have an exponent on a term that basically makes it not able to change sign. So I notice that here, this term has a squared on it. Okay, remember that a squared, anything squared, no matter what it is, the squared is going to turn it positive. And so if I have a squared term, that makes it a double root. And a double root means that you're going to have no sign change. So that means that when I'm listing the places where my sign change is going to occur, negative b should not make my list. Okay, now the x in the front, 0, that's an odd power, totally fine. X minus a, odd power, totally fine. X minus c cubed, odd power, totally fine. Okay, but any even powers or absolute values, you're not going to have a sign change of those. Okay, so your values would be 0, a, and c only. B is a potential, but then because of the power or the exponent that's on it, it ends up getting eliminated. Okay. All right, let's see what else. 74 is pretty similar. Ooh, okay, let's go to 77. So this graph is stated to be a derivative of the function of f. So if this is the derivative of f, that makes this an f prime graph. Okay, this is not a graph of f. So it says, for what value would my graph of f have a relative minimum? Okay, well, remember that your critical numbers are going to occur as the zeros on this graph. Now, let me rephrase. Critical numbers for f of x are going to be zeros on f prime of x. So remember, I'm trying to answer questions about a graph that I do not have a picture of. This is a graph of f prime. I'm answering questions about f, which is a graph I don't know what it looks like. So critical number here, 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 and here. Okay, however, when I set up my critical numbers, I need to look for a sign change. So let's do that right here. Okay, I have a critical number at -9. I have one again at -5. I have one at -1. Then I have one at 3. Then I have one at 7. Now, let's check the signs of f prime. So f prime is below, below, above, below. So it's negative, negative, positive, negative. What does that tell me about what f would have been doing? Regular f would have been decreasing, decreasing, increasing, decreasing. Okay, so remember, this graph's y values tell me what f prime's, what f's slope would have been. So I know that I would have a min at -1. I would have had a max at 3. At -5, I would have had what's called a non-extreme horizontal tangent, which means that my graph is going to go flat, but then it's not going to really turn all the way around. It's just going to keep going down. So let's write, we have a relative max at x equals 3. We have a relative min at x equals -1. Then it says, okay, what about concavity? When's my graph concave up? When's my graph concave down? Okay, well, if this is a graph of f prime, then f double prime, which controls concavity, is the slope of the f prime graph. Okay, so if I want to know about f double prime, I need to look at this graph's slope. So whenever I see a positive slope, I'm going to highlight it in blue. Okay, negative slopes, I'll go back and highlight in orange. So I see positive slope, positive slope, positive slope. That means that my original function f, which I do not have a picture of, but I'm trying to answer questions about, okay, would have been concave up on -7 to -5, union, -3 to whatever that is, 1, and then 5 to 7. Okay, my graph would have been concave down. F is concave down on. And then I would just look for where my slopes of f prime, which is really f double prime, would have been negative, which would have been here, here, and here. So that would have been from -9 to -7, union -5 to -3, and then from 2 until 5. Okay, then my last question says, okay, well then where do I have points of inflection? Now remember, that's not talking about this graph. This is when does f have a point of inflection? which I do not have a picture of. So I'd have to think about, okay, F has a point of inflection when F double prime changes sign. And then this is a graph of F prime, so that means F prime's slope, let's say slope of F prime, changes sign. And then typically, I'm sure you guys remember, or at least hopefully, okay, but I'll usually do X's for those. Okay, so I'm downhill X, uphill X, downhill X, uphill X, downhill X, uphill. So we have quite a few of those. So it's going to be X equals -7, -5, -3, +1, and then +5. Okay, because that's where F double prime, which is really just the slope of these graphs that we're looking at, that's where those change sign. Okay. All right, now 78 is a little bit more tricky. So this time it's a graph of F double prime, which is the second derivative. Now, I don't know if you guys remember from this homework, but F double prime does not give a lot of information about F. The only thing F double prime it can tell me is it can tell me what the concavity of F is. That's it. So if this is F double prime, then F is going to have a point of inflection when F double prime changes sign. So then I'm going to look at my graph and say, okay, well, I'm positive at the beginning, then I'm negative, that's below the x-axis, then I'm positive, then I'm positive. So my only points of inflection happen here and here. Now remember, this is a graph of F double prime. So if I want F double prime to change sign, I just need it to pass through the axis. So I know that that's going to happen at, oh, I colored on whatever that dot is right there. Why did I draw such a big dot? Hang on. Okay, so that dot looks like it was maybe an A. So that was an A. And then this would be a 0. So my F double prime changes sign at X equals 0 and A, because that's where this graph passes through the x-axis. Then F would be concave down whenever F double prime is negative, which means I would want the parts that are below the x-axis, so from A to 0. My graph will be concave up everywhere I'm above, which would be from -infinity until A union, and then 0 to B, and then B to infinity. And then remember, we also talked about that you are allowed to group these two pieces together. So you could just do -infinity to A union 0 to infinity. Okay, and then technically those would be the same. Either one of those answers would be acceptable. Okay. All right, we're getting there, we're getting there. Okay, let's see. Next one. We're doing a function f of x. Okay, it says we want to know which points on the graph meet the criteria described. Now we're specifically talking about the points that are labeled A, B, C, D, E. Okay, so the first one says I want f prime to be greater than 0. Okay, well, think about what that means. That means that f has a positive slope. Got to remember what those things stand for. So f prime is f's slope. So then I'm going to look at those points and determine which of those has a positive slope. Okay, so A, B, C, D, or E. Well, if I want a positive slope, I want to be going uphill. So A is fine, E is fine. Now, B, I'm interpreting to be flat. So if you were kind of thinking B, it's kind of questionable where it's at. But I'm going to say only A and E. Now, for F double prime, okay, F double prime, I need F to be concave down. because I want the second derivative to be negative, and the second derivative controls concavity. So I'm looking at my graph here. I can see that this portion of it appears to be concave down, and then somewhere between here and here, I can see my graph switches to be concave up. So it looks like only A, B, and C are concave down. And then somewhere between C and D, it looks like, I'm gonna put my little X here, there's a point of inflection and the concavity changes. Okay, then it says in part C, which points are the first and second derivatives negative? Okay, well think about, first derivative negative means that F is decreasing. And then if I need the second derivative to be negative, that means I also need it to be concave down. So look at your points that are left, A, B, C, D, E. Which ones are decreasing? Okay, well, I only see C is decreasing, D is decreasing. But then if I also need it to be concave down, then I'm really gonna only pick C. Then I need the first and second derivatives to have opposite signs. Remember, that means two choices. F prime can be positive with F double prime negative, or F prime can be negative and F double prime can be positive. So then I would want to kind of like skim through those equations and see which of those meet those criteria. Well, if F prime is positive, I need my graph to be increasing but concave down. For F prime to be negative, I need to be decreasing but then concave up for the second derivative. So let's do this one first. I want increasing, and then that's supposed to be a C. Concave down, well, that would have to be A. And then I want negative but concave up, well, then that would have to be D. Because I'm technically still going down, but I am on that concave up interval. So that would be A and D. Okay. All right. Good job. Okay, so next question on your review is about position, velocity, and acceleration. Okay, so we have a position that's given to us, and then we're asked when the particle is at rest, whether it's traveling towards or away. We're asked questions about speed, etc. So let's just kind of start at square one. So if I want to know when the particle is at rest, if it's at rest, it's not moving, that means its velocity needs to be 0. Velocity is the derivative of position. So V of t equals, derivative of this would be 6t squared minus 2 times 2 is going to be 4t plus 1, the derivative of that is 0. Set that equal to 0, take a 2t out. That's going to give me a 3t minus 2, which means that my particle is going to be at rest at 0 2/3. Now, one thing I do want to point out to you is that, remember, we talked about when you're doing particle motion, there's no such thing as negative time. Okay, your time has to be positive, or it can be 0, but it can't go back to the negatives. So that means that this actually starts at 0, 2/3 moving forward, but I can't go backwards past 0. So let's say I pick a number over here. Let's say I pick 10. 3 times 10 is positive, minus 2 is positive, multiply it by 2 times 10 is positive. That means that that's negative. So my particle would have been traveling to the left from 0 to 3. It would have been traveling to the right from 0 till infinity. Or I'm sorry, from 2/3 until infinity. Okay, now remember, those correspond directly with, I'm traveling left when my position is decreasing, right when my position is increasing. Okay, next question says, when is my particle traveling towards or away from the origin? Okay, specifically at 1 is the time that I care about. So in order for you to answer this question, Okay, towards or away from the origin, you need to know two things at one, the position at one, and then the velocity at one. Okay, now that's a pretty easy number here for us to plug in. My original position function was 2, 1 cubed minus 2, 1 squared, and then plus 1. Well, 2 minus 2 is going to cancel, so I'm going to just get positive 1. Come up here to my velocity. 6 times 1 squared is just going to be a 6, minus 4 times 1 is just going to be a 4. 6 minus 4 is 2. So I got a positive for both. Well, let's talk about what that means. If my position is positive and I'm on the x-axis, because that's what it says right here, okay, then that means that I'm on the right side. And also, if my position is positive, or I'm sorry, if my velocity is positive, then I'm traveling to the right as well. So I'm already on the right side, and also I'm traveling to the right. Then therefore, I'm traveling away. Okay, now if it says to explain, you have to put this stuff. I'm on the right side, I'm traveling to the right, therefore I'm going away. If it doesn't say, you can just guess towards or away. Okay, but those points will be tied together, that if it says towards or away, justify, and you just only pick one, okay, then you're not going to end up getting points. Okay, next one asks you about speed. Okay, so speed, you're looking for velocity at 4 and acceleration at 4. Okay, so again, this is still an agreement of signs, but instead of position and velocity, now it's velocity and acceleration. So let's go ahead and do velocity since we've already taken it. It's right here. So I would have 6 times 4 squared minus 4 times 4. 4 squared is 16. 16 times 6, I don't even know what that is. Okay, but I know that if I take away 16 from it, it's going to come out to be positive. Okay, so 6 times 16 is like, I don't know, 84 or something like that. So if I minus 16 from that, I know it's positive. I don't even care about the number. I just care about the sign. Now, acceleration, I have not actually gotten to yet. So if this is velocity, I still need to take acceleration before I can plug in 4. So let's do that over here to the side. So if my v of t for velocity is 6t squared minus 4t, then my acceleration is the derivative of that, which is 12t minus 4. Okay, which means that from there, if I take out a 4 from there, I'd have 3t minus 1. Oh wait, and actually I don't even have to do all that. I could, but we have a specific number we want to plug in here. So if a of 4 is what I'm looking for, then I want 12 times 4 minus 4. And then again, I don't care about the number, I just care about the sign. 12 times 4, that's 48. Okay, 48 minus 4, I know that's positive. I don't even care about the value, I just care about the sign. So if I'm positive for my velocity and I'm positive for my acceleration, then my speed has to be increasing. Remember that my answer would not change if they were both negative, because all that has to happen is that they have to agree with each other. Okay? So I'm going to put speed is increasing because v of 4 and a of 4 have the same sign. Okay, I scribbled over this one, so you can skip part D. Okay, let's see. What else do we have here? All right, we're almost there. Let's see, number 84 is a good question just about calculator skills. So they already give you the velocity and they're just asking you basically to graph that. So if you take your v of t, put this in your calculator, okay, then we're going to sketch the graph to the right. So let's start off with that. Double check for me, please, before you graph it. You do want your calculator to be in radian mode, okay, which is usually the default setting unless like somebody messed with it. So -5 cosine x minus x to the power of 3 divide by 2 and then plus 5. So -5 cosine x minus x to the 3 over 2 and then my plus 5. Okay. Now, I'm also paying attention to this domain here. I only really care about this 0 to pi. So if I were to hit graph on this right now, okay, there's a chance this graph is going to look pretty crazy because I'm only really needing, oh, actually it looks totally fine. Okay, but I only really care about 0 to pi. So let's take my window in 0 to 3.14, which is my pi symbol right there. Okay, so let's hit graph on that. Oh no, I forgot to change my min. Just a sec here. Okay, so I'm going to go back into my window and I'm going to change my minimum to be 0. Okay, because remember that time cannot be negative anyway. It wouldn't even make sense for me to leave it like that. So it looks like my graph starts right here. It goes up and then down. So this is a graph of velocity. This is v of t. So when is the particle moving to the right? When is it moving to the left? It's going to move to the right when velocity is positive. It's going to move to the left when velocity is negative. And remember that that is going to be indicated by the y value of this graph. I'm positive at the beginning, and then I'm negative at the end. So this first interval, my particle would have been traveling to the right when it's above the x-axis, but then to the left when it's below. Now, that means that this point right here is going to be the cutoff. I need to find that. So second trace, go down to 0, and then I can count. If this is 3.14, that means this is 3. So it happens somewhere between 2 and 3. So you can do the little arrow thing, but I'm just going to do 2 is my left bound, 3 is my right bound. And then guess, I don't care, I'm just going to push enter. So I can see now that that's 2.6624. Okay, remember, if you go to 4 decimals, you can just cut the decimal off. You don't even have to worry about rounding. So my particle is going to be traveling to the right from 0 to 2 point, whatever that is, 2.6624. It's going to be traveling to the left from 2.6624 until pi. Remember, you do not want to overextend your interval. If the interval ends at pi, you make your graph cut off at pi so that you don't forget. If it starts at 0, you make your graph start at 0 so that you don't forget. Okay, then it says, what is the velocity of the particle at pi 6? What about the acceleration at pi 6? Okay, that's a great question. So if this function is velocity, then I want the y value at pi over 6. So here's what I'm going to do. I'm going to find the velocity of pi over 6. Then I'm going to find the acceleration at pi over 6. Okay. Now, if I were to try to go into my table to look for this, right? Velocity is my y value, but unfortunately, my table only goes up in whole numbers, not in pi 6. So what I can do is the same thing I showed you guys yesterday. Go into your normal calculator mode. You do have to have the equation typed in here already. Okay, but in my normal calculator mode, I'm going to hit alpha trace. I'm going to choose y1, okay, right here, and then I'm going to plug in pi over 6. Okay, and it'll give me that value. So the y value at pi 6 is 0.5980. 0.5980. Now, let's say that I want the derivative. Remember, we can do that in the graph. So I'm going to hit second trace. I'm going to go down to dy dx, which is the derivative button. And then it's going to ask me the x value. So I'm going to put in pi over, pi over 6, just like that. Okay, so my slope came out to be 2.0887. 2.0887. Okay, so this included me taking the derivative, which is second trace number 6 dy dx. Okay, and then this was just the normal y value, which I used alpha trace for. Okay, you can also modify if you're good at like changing the table and stuff, that's fine as well. So then the next question says, okay, what about speed? Is the speed increasing or decreasing? Well, my velocity came out positive. My acceleration also came out positive. So if these are both positive, that means that my speed is increasing. Okay, at t equals pi 6, because the velocity at pi 6 and acceleration at pi 6 have the same sign. And then remember, it doesn't matter that they're both positive, it only matters that they match each other. So if they were both negative, that would also mean that your speed is increasing. Okay, then it says, what is the acceleration in terms of t? Okay, that means they want me to take the derivative. So I'm going to rewrite my velocity here. It tells me that v of t is -5 cosine t minus 1/2 t cubed, okay, plus 5. The reason I'm going to change the way that that term looks is because I don't like that it looks like quotient rule. So I'm going to separate that into a 1/2 and then a t cubed so that I remember it's not a quotient rule. Okay, so then acceleration a of t equals -5 cosine, derivative of that is +5 sine t. 3 times 1/2 is going to be -3/2 t squared. And then the derivative of +5, that's a constant. So the derivative of that is 0. So that would be your acceleration. Okay. All right. Very good, very good. Almost done. Okay. I do not want to do all of this last page. I want to do a couple of them, and then there is one related rate that I wanted to kind of jump back to if we have time. So if you'll take a look at your back page here, okay, you have all these different functions, and we're trying to take derivatives of them. So you're just going to have to think about your 3 rules, remember? So it's just regular derivatives, product, quotient, chain. So if I was trying to do, let's say, B here, okay, B is a pretty middle of the road one. If I want the derivative of g of, and then in the middle, I have a 3x minus 4, that is going to require me to do chain rule, okay, because it's not g of x times 3x minus 4, it's g of, and then inside that, 3x minus 4. So when I take the derivative of that, I'm going to have g prime of 3x minus 4. And then I'm going to multiply by the derivative of the middle, which is going to be an extra times 3. Okay, now that would be the derivative anywhere. Then I want the derivative at 3. So then I would want g prime of 3 times 3 is going to be 9. 9 minus 4 is 5. And then I would use my table. So g prime of 5 is 3. 3 times 3 is 9. Let's go ahead and do a double. Let's go down to letter E. So we have the sine of the f of, and then 3x. Do I have another color? Yes. a 3x in the middle. Okay, so my outside function here is going to be sine. Okay, the derivative of sine is going to be cosine. And then remember, inside cosine, your f of 3x stays the same. Then I move to my green layer, which was an f. So the derivative of f is going to give me an f prime of 3x. And then I move to my inside layer, which is my 3x. The derivative of 3x is a times 3. And then from there, you're going to take whatever number they want you to plug in, go ahead and do it. So if I want x to be a 1, whoop, that's going to be the cosine of f of 3 times 1 is f of 3. 1 in here is going to be f prime of 3 times 1, which is 3. And then I'll evaluate these two values from my table. So if I come up to the table at 3, I can see up here that f of 3 is going to be 0. F prime of 3 is going to be, oops, you can't see that. F of 3 is going to be 0. F prime of 3 is going to be 6. So that means that I have the cosine of f of 3, which is 0, times f prime of 3, which is 6, and then times the 3 in the back. Then hopefully we know cosine of 0 is 1, 1 times 6 is 6, 6 times 3 is 18. Okay. Then I'm noticing here that on F and G, we have not covered inverse derivatives yet, so you can skip those too. Okay, we will cover those. Typically we would have, but just because of the way the year's gone, we're not quite there yet. So you can cancel those two or just cross them out. Okay. The one related rate that I want to go back and cover is number 65. Okay, so go back to number 65. So it says a particle moves along a curve xy plus x equals 6. Then it says that x is 3, dy dt is 5. What is the value of dx dt? Okay, so they're not being very cryptic here with their find given when, right? So they're telling me to find dx dt. They've given me dy dt. They've told me dy dt is 5. And then they're telling me my when is that x is 3. Now, keep in mind, x is not always 3, but it's 3 at the moment that I care about this situation. Okay, so when I go to take the derivative of this, maybe don't write here, but I'm going to write up here. Okay, it's xy plus x equals 6. This term has x's and y's mixed together. That is going to require product rule. So my u is going to be an x. My v is going to be a y, which means my u prime is going to be a dx dt, and my v prime is going to be a dy dt. And so then when I take the derivative of that first term, I'm going to have x dy dt plus y dx dt. Then the derivative of x is just going to be a dx dt. And then the derivative of 6 is going to be 0. Then from here, I'm going to go ahead and plug in all the stuff that I have. So dx dt is my unknown. That means that I'm not planning on knowing this, and I'm not planning on knowing this. Okay, but everything else I should know. So I'm like, all right, well, let's go. So I have my x is a 3. My dy dt is a 5. Plus y times dx dt plus another dx dt, and then it's kind of like, well, wait a second, something's wrong here. Okay, I'm supposed to know this. If I don't know this y, then there's no way I can solve for dx dt, because then I have too many things I don't know. I can only afford to have one thing I don't know. So you're going to have to go back and think about, if x is 3, how can I go back and find y? Okay, well, I can go back to my original equation and plug in. So if x is 3, remember the original equation is where we go back and find the stuff we forgot to go back and find at the beginning. So my x is a 3, that's 3y, plus x is another 3 equals 6, minus my 3 across. That means that 3y equals 3. Divide by 3 on both sides. That means that my y is a 1. Okay, but remember, it's always the original equation that you're going back to find those missing details that you forgot to get. So I have 3 times 5, that's a 15, plus my y is a 1 dx dt, plus another dx dt, and then equals my 0, because remember I took the derivative of 6. Well, then that means that 15 plus 2 dx dt's, because I'm just going to combine those, equals 0, which means that 2 dx dt is going to equal negative 15 when I subtract that across and then divide by 2. Which means that dx dt is going to be negative 15 over 2. Okay. All right. Very good. So you basically have the rest of the period, the week, whatever, to work on this. I will have Zoom tutorials on my normal Zoom on Sunday. Okay, I have to remember what time I said. I think it was 1 to 2:30 or something like that, but let me double check that before I get you guys offline. Okay, so Zoom tutorials on Sunday are going to be from 2 to 3:30. Okay, if you have any questions off of this review, okay, and then that is the Sunday of, what is this, the 13th. Okay, if you have any questions off of the reviews, off of the homeworks, I realize that my little honeymoon is coming at a pretty terrible time of the year as you guys are trying to figure stuff out. So if you have any questions off of homework or whatever, okay, log on to the Zoom, message me if that time doesn't work and I can work around it, but we'll figure something out, okay? So your review is due. It's a test grade for this quarter. Please don't blow it off. And I will see you guys back on Sunday if you come to tutoring. And then I'll see you in person or on Zoom on Monday. Y'all have a wonderful week and a wonderful weekend.